Hello everybody and welcome back to another mini project tutorial here. In this video we're going to be building out a simple memory game. So here you can see I have all of my cards and I can click on them and it's going to flip over and show me the picture, and then whenever I get a match it highlights that match green. I can also change the number of cards on my screen that are displayed. So I can go all the way down from 2 pairs for like a little kid all the way up to 9 pairs on this game for a bit more of a challenge. And then also I've got this little turkey icon down here. So if I click on that, it's actually going to toggle our theme. So because it's October now, the end of October, I went ahead and put a Thanksgiving theme, a Halloween theme, and then a Christmas theme on this memory game. So you can see how we're toggling themes there as well. So let's go ahead and get started building this. So without any more ado, basically all we need to do is create a new project. And this new project, we're just going to choose this empty compose activity. For the name, I'm just going to call it memory. And we can go ahead and just delete out this standard greeting that comes with the empty project by default. We don't need any of that. Now, let's come on over into our Gradle scripts, open up our Gradle file here. You can see we have our compile SDK set to 33. So 34 is actually out, so we're going to need to update that to 34. And then let's come down here. All of this we can leave the same, but I am going to go ahead and update this from 1.9 to 1.12 for that Android X core. And as far as dependencies go, that's really all that we need. We're not going to need anything else in addition to that. Let me just give us a quick package structure here. So we've got our SkyFish, here's our memory project. Now typically, right, in clean architecture, you're going to have a different package in here for every feature. So let's go ahead and just add a new package. And we'll just call it memory feature, but really that's all that we're going to put in this app, so it doesn't really matter, but I'll just do that anyway. Package, and we're going to say presentation. And typically you have your presentation layer, and then you also have your domain layer, and then you would usually have a data layer, but we're actually not interacting with any data here. So we don't have any database, we don't have any retrofit pulling in remote data. So I'm just going to leave it at our domain and then our presentation. In the domain, I'm going to put a model layer in here, and that's going to pretty much just be for our card model. That's going to represent what our card looks like. And then in here, we'll do one more package, and that can be util. And then under presentation, we're going to do a package for util, and then also a package for memory screen. Let me drag this main activity up into our presentation. And then finally, in this UI theme, I'm just going to add a couple different colors that we'll be needing in this activity. So because you can see on this phone here, because you've got this picture on the background, and then all of these colors are basically matched with the images. And I don't have two sets of images for dark theme and light theme. So what we're going to do is we're just going to have only one theme for this app, no dark and light choices. So to do that, we're just going to put some extra colors in here. And I'm just going to copy this colors object into here. So you're welcome to pause the video right here and just copy down all of those values. But you could just grab it from our GitHub page because I'm about to commit this setup code in just a minute. But before I do that, let's come down to resources, drawable. I'm going to paste a few images into there. And you can see this is going to be all of our background images, the backs of the cards, and then I have a bunch of icons, 1 through 9, for the actual pictures on the cards. And that should be everything. So let's click add on that. And all of those will show up in there. And then one more thing I'm going to add, we're going to do new image asset. And you can see here we've got that default ugly green Android. We don't want that. So I'm going to get out of that. And I have this fall icon that I've created that we're just going to use for the memory game instead. So that's in my temp folder here. And then I just called that fall icon, I believe. And this one I just pasted into that drawable folder too. So you can pull that from the GitHub. And there you go. There's our fall icon. So let's hit next and then finish on that. And now you've reached the checkpoint for our setup. So all of this code at this point will be up on GitHub. You can pull that down and then continue on with the project. At this point, the next thing we need to do is go ahead and build out the model that we're going to be working with. So for that, I'm going to do domain and then model, and then in there, we're going to do a new Kotlin class or file. And this is actually going to be a class. I'm going to call this memory card. Okay, and then inside of this memory card, we basically need to define what our card is going to look like. So first thing, let's add a couple parameters up here. We're going to say var value is going to be of type int, and we're going to basically assign a number to every one of these cards. And then that number is going to correspond with one of those images that we just imported into our drawable folder. But what we're actually comparing is the number on the card rather than the image. And then we're going to have that value to compare. Then I'm going to have is back displayed, and that's just simply going to tell me if the back of the card is displayed, meaning is it flipped over. So we'll have that set equal to true by default because they start off with all the backs up. And then one more, we're going to say match found, and that's going to tell me whether this card has already had its match found. So we need to actually exclude it from all of the logic at this point because that card is done in the game. So we'll set that equal to false by default because again, that match is not going to be found in the beginning. And then finally, we're going to have this fun flip card. And this is just going to be a function to turn that card over. So basically, whenever I click on one of these cards, I need to flip it over and show what's there. And if it doesn't match, then I need to flip it back. So to do that, all we're going to do is toggle this is back displayed value. So we can say fun flip card is back displayed equals not is back displayed. And that is really all that we're going to need for that. So now we can actually go on over and build a state here. So to do that, let's come on out of our model, out of our domain class, and come down into our presentation in our memory screen. So I'm going to say new Kotlin class or file, and this is going to be a memory state, which is going to be a data class. And then inside of this memory state, we're going to have a couple different pieces of information. So we have val cards, which is just going to be an array of memory cards. And then we're going to have the two different cards that we need to compare. So I'm just going to call those card 1, which is going to be a nullable int. And this actually is not tracking the card as in the memory card object, but rather the index of that card where it's displayed on our grid. So I'm going to say card 1 is going to be a nullable int by default set equal to null. And then card 2, which is going to be the second card that we flip over, is also going to be a nullable int by default equal to null. And then after that, we do need to track a few more pieces of information. We need to track our pair counts. And this is basically going to tell us how many pairs of cards that we have. And by default, I'm just going to leave that at 6 right in the middle because you saw on that app, I'll show you here, we can come all the way up to 9 pairs, all the way down to 2 pairs. And 6 is just a nice happy medium number. So I'm going to set it equal to 6 by default. And then after that, we need pairs matched because whenever our pair count is equal to our pairs matched, we know the game is over. So I'm going to say pairs matched, which is going to be an int by default equal to 0 because you haven't matched any pairs at the beginning of a memory game. And then we're going to track the counts as well for a score. So we'll say click count is of type int equal to 0 because we haven't clicked anything in the beginning. And then one more that we'll come back to in a minute is we're actually going to track our current theme down here. So val current theme is going to be a theme equal, we'll actually name this a holiday theme, which is going to be equal to, by default, our Thanksgiving theme, which we have not actually defined yet. So we'll do that in a little bit. But before we come to that, I need to look at what to actually assign this cards array to in the beginning. Because basically what we're going to need here, if we need to track the values on these cards, this needs to essentially be an array that has 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. But we can't have it just like that because then all of our cards are going to be right next to each other. So we need to shuffle that up. So to do that, I'm going to actually come up here into our model util. We're going to do a new Kotlin class or file up here. And I'm just going to call this functions. And then in our functions file, we're going to have a function in here for generating a new array. So fun generate cards array. And then in here, I'm going to hand it our matches count, which is of type int. And then we're going to hand back an array of memory card. And this is what we're going to use to populate that. So in our memory state, basically we need to say this is equal to generate cards array, and then this number needs to match this pair count. So we're just going to say 6. Now let's actually go and write the logic for that function here. Now in here, to actually generate that array, basically I'm going to need a list of, or a range rather, of our numbers from 1 all the way up to the number of matches that we have. So here our matches is going to be defined by that parameter coming in. So I'm going to call this our singles, which is equal to 1 dot dot matches. And then our doubles is just going to be equal to singles plus singles. So basically what we've done is we've made a range from 1 up to the number of matches that we want, and then we've added that range back to itself. So now we have 2 of every card that we want. And now to get that shuffled into a memory card array, all that we need to do is say return doubles dot shuffled. And then we need to map this back to a typed array of memory card objects. So to do that, we can say dot map. And in here, I'm going to say memory card, and pass it. And then we can say to typed array. And that's all that we need for that. So let's come back to our memory state. Now, the one thing we have left to do in here is actually define what this theme is going to look like. So again, I already mentioned that we're not using the light and the dark themes that come with this by default. So let's go ahead and make a new file in here. This is going to be a new Kotlin class or file. We're going to actually make this an interface, and I'll show you why in a minute. We're going to call this holiday themes. So basically, our holiday theme is going to have everything that we need to define what the background is, what our card backsides look like, and then what all of the images on the cards itself looks like. So to do that, I'm just going to add some variables in here. So val, we're going to say background portrait, and that's going to be an int. Then we say val, we need our background for the landscape. Background landscape, which is also going to be an int. And then, whoops, we don't need commas after here. This is an interface, not a data class. So we've got the background for the portrait and landscape. Then we need a val for the back of our card, which I'm just going to call card back, which is also going to be an int. And then after the card back, we need the base color for what the card is going to be when you flip it over. What's the background color going to be? So I could say val, this is going to be card base color, which is going to be of type color. And now we need our text color, because on that card, if you look at it, you've got the base color on the card, and then you also have this text color on the question mark, because this question mark is not a picture, that's actually text that we're writing there. So to do that, we're going to say val text color is going to be of type color. And then after that, we can say, let's see, the val card. We're going to have a front base color as well for just what goes behind that image. Just because when it's loading, it can appear for just a split second, and it's better to have that be a color that matches with the image instead of clashes. And then after we have our front base color, we're going to say matched outline color. So val matched outline color, also of type color. And then finally, we're going to have an image map for the map of all of our images from, if you look in this drawable, you've got 1 all the way through 9 for Christmas, 1 all the way through 9 for Halloween, and 1 all the way through 9 for Thanksgiving. So basically, we're going to map all of these images to integers, 1 through 9. And then when we're actually comparing our cards, like I said earlier, we're not comparing these images with each other. We're comparing the value on the memory card object, which is this integer here. And that way it's just a lot easier than comparing if pictures match. It's much easier to compare if numbers match. So to do that, back in holiday themes, we are going to have a map here. So val image map is of type map, and we're going to say int. And then finally, we're going to have two functions in here, fun get image resource for number, which is just going to return the image that corresponds with the number in our image map. And that is going to take a number in, which is going to be of type int. And that's going to return back a nullable int, which is going to be that picture. And then after that, I can say fun get next theme. And basically, this function here is going to return a, whoops, not a theme, a holiday theme. And let's actually refactor that without the S. So rename, and let's just do holiday theme. This is going to return the next holiday theme so that whenever I click on this button here, you can see I switch from Thanksgiving to Halloween to Christmas. And why are these not in chronological order? Well, they are if you're Canadian. If you're American, I'm sorry, you can mix it up if you want. So there we go. We've got all of that in there. Now we need to actually make classes that are going to inherit from this interface to define all of our themes. Let's go ahead and start with our Thanksgiving theme. So class Thanksgiving theme. And this is, of course, going to inherit from our holiday theme that we just made. So holiday theme, and then we'll put the body down here. Now up here, we need to define all of these variables that we've created. We need to actually give them values. And I'm going to do that in the constructor with default values, just so that we can switch between these really easily. And basically our default constructor is going to build the entire theme for us. So in here, we're going to need to go ahead and do that. We could say override val background portrait. So our background portrait is going to be equal to r.drawable dot. And then in here, we're just going to say, let's go ahead and import that R so that everything shows up in our autofill. So background, and we want background portrait Thanksgiving. And then after that, I can say override val background landscape is going to be equal to r.drawable dot. And then this is going to be background landscape Thanksgiving. And then after that, we need to define the back of our card. So I could say override val card back. And this is going to be an integer, which is equal to r.drawable dot. And here we're just going to say card. Oh, let's see. We've got card back and then card back Christmas and Halloween. So let's do card back and actually find that. Let's verify that. Yeah, that's the image that we want. So let's rename that actually. So refactor, rename, just so that this makes a little more sense. We can say card back Thanksgiving. And there we go. We've got our card back defined. And then after that, we can do override val card base color. This is, of course, a color, which is going to be equal to here for Thanksgiving. I'm just going to do in our colors object that we added, we have this tan. And if you look on there, if we look on our phone itself, you could see that I've got that tan color on the back of the cards, and I think that looks rather nice with this theme. So we're going to leave it at that. So back in our holiday theme, I'm going to say our card base color is going to be equal to colors dot tan. And then after that, we need to do our text color. So val, override val, our text color, and this is also going to be a color. And in this case, we're just going to have that be the same, colors dot tan, the same as that background color. And then after that, we need to define our front base color. So I can say override val card front base color, and this is going to be equal to colors dot brown. We'll do here for Thanksgiving. And then here I need to actually define, our matched outline. Let's do that too. Override val matched outline color is going to be equal to, and this is going to be colors dot dark green, which is another one that we added into that colors object. And then after that, I need to actually define this image map here. So to do that, I'm going to say override val image map, and this is going to map an int to an int, and this is going to equal map of, and then in here, let's go ahead and, whoops, oh, hang on, image map colon map. This is a map of int to an int. And then in here, basically, I'm going to say 1 to r dot drawable dot tg1, which stands for Thanksgiving 1. And now I can copy that line and paste it 9 times. So now I just need to switch all of these. So I could say 9, 8, 7, 6, 5, 4, 3, 2. And then same thing over here. Say 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so that maps an integer of 1 to each of our images that we're using for our theme. And then after that, we have these 2 functions that we need to go ahead and implement. So for that, let's go ahead and do that down in the body here. And I can say override fun get image resource. I'm going to call this get image resource for number. And instead of doing not yet implemented, all we have to do is say return image map. And this is just going to be this number parameter that's passed in. And then after that, we can say override fun get next theme. And here, this is going to return a holiday theme. And inside of here, all I'm going to do is I'm going to set Thanksgiving to Halloween, and Halloween to Christmas, and then Christmas back to Thanksgiving. And we're just going to go in a circle. So I'm going to say return Halloween theme, which leads me to the next issue is that we haven't defined that. So basically, to make another theme for Halloween and Christmas, it's going to be just as easy as what we did here, where we're just assigning all of these variables in the constructor to all of that. And because I just showed you that, that's rather repetitive. I'm just going to go ahead and copy all of that and paste it down here. And you are welcome to, oh, that's not right. Holiday theme. So need to copy that. My notes, I named that slightly differently, so we're going to fix that here. Okay, so you are welcome to go ahead and copy all of this. The one thing that it looks like we're missing here is I've got colors.orange, and in my color, do I have an orange? I do. So why is that not working? Override val, reset icon color. Oh, I need to, did I skip that up here? Yeah, so let's add a reset icon color as well. So val, reset icon color. This is going to be of type color. And then we need to actually define that down here as well. So I can say override val reset icon color, which is a color, and that's going to be equal to, for Thanksgiving, that's going to be brown. And let me show you what that reset icon is here in this code. That is just this little reset guy down here that resets everything, and it's just defining what color we want those to be. So we'll leave it brown in Thanksgiving, and then for Halloween and Christmas, they should all be good now. If you want to just copy that code, go ahead and pause the video right here, and you can grab the Christmas theme, or if you want to grab the Halloween theme, you can copy this code right here and grab that, or you can just go to the GitHub and copy these, or even better, you can just make your own themes for this because these are just images. It really doesn't matter what images and colors that you use. You are here to learn Kotlin, so let's be done with our themes and get into actually learning some Kotlin now. So the first thing we need to do is come into this memory state and go ahead and import that class that we just created for the theme and import the theme as well. And now that we've got that, we can close out of our state. We're done with that. We're done with our memory card. We're done with all of this. So I'm just going to close all of these out to clean up what I have open just a little bit. And then at this point, we need to make an event for anything that can happen inside of our memory screen. So we're going to do new Kotlin class or file. And this is going to be a sealed class because basically it's going to be a finite list of all of the different user interactions that we can have. And then we're going to pair that with a when statement in the view model. So I'm going to call this our memory event. And then inside of here, we are going to have a data class card click. And this is, we're going to pass in the ID of the card that's clicked. So I can say val card ID of type int. And then this is going to be a memory event. And then after that, we're going to have a bunch of objects. So object, add pair. And this is going to also be a memory event. And let me just copy that a few times. So paste that maybe a few more times, one more time. So we have add pair. Then we're going to have reduce pairs. So this is for increasing. This is for decreasing. And then we're going to have change theme. And finally, we're going to have one last option for the user to interact with called reset game. And there we go. That's really everything that we're going to need here. So inside of the sealed class, we have our data class. And basically, you use a data class whenever you need to pass in parameters to your event. And then you just use an object whenever you have an event where you have no parameters needed. So here, the only one where we actually need a parameter is the card click. So now with that event in place, we can actually go ahead and start building out our view model for this. So same thing, back over to the memory screen, right click, new Kotlin class or file. This one is going to be a class and I'm going to call it memory view model. And this is actually going to inherit from our view model class. And inside of here, let's go ahead and add a state. So private val state is equal to a mutable state of, and then I can say memory state. Make sure to import this mutable state of. And basically, this is going to be our private read-write state variable that we can read and write from inside of our view model. But now we actually need to view that state from outside of the view model, but we don't want to get write permission, only read permission. So to do that, we always have this private state up top. And then after that, you just make a public state. So val state of type state. This is going to be a memory state. And all we're going to do is set this state equal to our private state. So what that is going to do is, of course, give our UI the ability to read our state without actually being able to update our state object. And then after that, we're going to need one more job for basically when you look on this application here, if I click on some of these, you can see it doesn't match, but it doesn't flip back immediately because I need the user to have some time to see what the card that didn't match was, so that next time they can actually remember where that card is and play memory. So to do that, we have a delay function going on, and we are going to need to save that in a variable because you'll also notice on that same game, if I click 2 and wait 2 seconds, it's going to flip it back. But if I click 2 and then click another one immediately, it flips it back. So basically, we have this delay job that we need to cancel if and when the user clicks another card, because we don't want to have 4 or 5 cards visible at one point, because that's not how you play memory. So we're going to call this private var delayed compare job. And this is going to be a nullable job that's initially equal to null. So let's go ahead and import all of these. And then we should be good to go there. Now let's go ahead and make our onEvent function down here. So the reason that we make this memory event is because the UI is going to be throwing all of these events. And whenever the UI sends one of these events back to our view model, what we need to do is handle these, and because it's a sealed class, we can handle that very easily inside of our when statement. So down here, I'm going to say fun on event memory event, and then inside of here, all we need to do is say when event, and whoops, we need to spell it right. So when event, and now it's going to give us an error because it says you haven't exhausted all the necessary conditions. But to do that, we just click more actions and then say add remaining branches, and there we go. So I'm going to replace all of these with my brackets because we're going to have functions in there. And basically, all we need to do now for the rest of the view model is fill out all of these. So let's go ahead and start at the top. So whenever I click add a pair, basically what that's going to be doing on our phone here, whenever I click this button, it's going to increase the number of cards on that. So to increase the number of cards on my screen, I actually need to increase the number of cards saved in my state. So this pair count needs to go from 6 to 7 to 8 to 9, or all the way down to 2. So in my view model, to do that, all I need to do is increase my matches, but just to keep things a little bit cleaner, I'm going to actually make another function to do that. So down below my onEvent function, we are just going to make a few functions. I'll say private fun increase increase matches rather. Increase matches. And then inside of here, all I need to do is say if we're going to say state.value.pair count is not greater than whatever our maximum number is. So here, our maximum number is 9. And the reason that our maximum number is 9 is because if you look in our res folder, and if you look in our drawables, you can see I only actually have pictures from 1 all the way to 9. Obviously, we could make that whatever we wanted if we continued to add more, but I only have that many pictures, and I'm not going to go download more pictures right now. So to do that, we're just going to leave that at 9 just to work with that. But I don't really like having that in the code just as a number. So I'm going to do a new Kotlin class or file, and this is just going to be a file that we call constants. And now inside of our constants package, I'm just going to have an object, and this is going to be our numeric values. And inside of here, I'm going to have a const val max pairs, and that's going to be equal to 9. And then while I'm at it, we'll just add the minimum pairs as well. So const val min pairs is equal to 2, because you can't play memory with less than 2. So we're going to leave it at that. Come back on over to our view model. And then inside here, so if our pair count is less than 9, then all we really need to do say state.value is equal to state.value.copy. And then inside of here, I just can say pair count is equal to state.value.pair count plus 1. And you'll notice every time in my view model, whenever I'm referencing that state, I'm using that underscore state, which is, of course, our private state variable. So this is read write within the view model. And then this is our public read only for the UI. So in the view model, we always use that underscore private one. So there's our increase matches. I can just go ahead and copy this function now. And we're going to rename this to decrease matches. So decrease matches, and this is going to be whenever this is greater than 2. But actually, I made those constants. I'm not actually using them. So numeric values dot max pairs, and then down here instead of 2, I'm going to say numeric values dot min pairs. And now instead of plus 1, all we have to do is minus 1. So that should take care of 2 of our events right there. So come back up to our on event, and whenever we get an add pair, basically we need to run increase matches, and whenever we get a reduce pair event, then we need to run decrease matches. But there's one more thing that we're going to need to do here, because if I say I come all the way down and I have a match, right? So I've got a match right there with my pumpkins. If I now click increase, I don't only want it to add 2 cards, I want it to reset these back to the backflowing, and I want to start the game over, because otherwise I click, get a match, and then I click up and I have only 4 showing. I get one more match, click up, and now I have 4 showing again, and it just makes the game it gives the user an ability essentially to cheat to get a low click count. And we don't want that. So every time that we click one of these arrows, what I want to do is actually reset the game back to normal too. So down here, I'm going to make a reset function as well. So this is going to be private, fun, reset game. And then in here, basically all that we need to do is create a new value of our state. So to do that, I'm just going to say state dot value is equal to a memory state. And then inside here, there's a few things that we're going to want to save. If we're resetting the game, if you remember in our memory state, we had this defaulted to 6, but that's obviously what we're trying to change. So we're going to want to save that. And then we don't want our theme to go back to whatever it was every single time the user changes how many cards are on the screen. So we're going to have to save that. So let's go ahead and do that. In here, we can say that state.value equals a memory state. And then inside that memory state, I can say pair count is equal to state.value.pair count, because we're going to want to retain that value. And then I can say current theme is equal to state.value.current theme. But we'll still have one problem here. And if you look in our state, you can see we have this pair count, and then we have the number up here for our matches that we're passing into our generate cards function. So to fix that, all we're going to do back in the view model, I'm going to override that one as well to not use the default. So I can say cards is equal to generate cards array, and this is going to be state.value.pair count. Okay, and now that we have that increase, decrease, and reset, I need to come up here, and after we increase, we need to reset our game. And then after we decrease or reduce pairs, we also need to reset our game. And then whenever we click the reset, that is going to be super easy now. We just have to reset the game. So now for change theme, all we have to do here is if we look in that theme that we made, we had that next theme button or function rather. So for example, Halloween theme, I have get next theme returns Christmas, Christmas, get next theme returns Thanksgiving, Thanksgiving returns Halloween. So this is just going in a loop. Obviously, if we were planning on adding like 100 themes to this, we might want to make that like consider a way to make that a little more dynamic rather than just hard coding. But with 3 of them, it's not a big deal. So for the change theme, all that we need to do here is basically say state dot value is equal to state dot value dot copy, and then our theme. So our current theme is going to be equal to our state dot value dot current theme dot get next theme. So now that's going to hand everything back for a change theme, and now all we have to do is handle what happens on this card click event. So to do that, I'm actually going to just put this in another function down here. So we're going to say private fun on card click, and I'm going to put all of the code in there. But for now, I'm going to copy that up here, paste it in there. And again, this card click, you'll remember if we look in our event, that actually has a parameter card ID coming in with that. So back in the view model, for our on card click, I'm going to go ahead and add a parameter to that as well, which is just going to be an ID, and we're going to call that an int. And after that, we need to actually pass that up here. So I can say event dot card ID. And then in this on card click, if we look again at our phone here, so if I click on one of these, we need to wait 2 seconds. But if they actually match, then we don't wait 2 seconds. We immediately mark that green and let the user continue on. So we need to know basically if we need to cancel this event or not. Also, if I click too fast, I need to cancel that event if I click faster than the 2-second limit that I set. So before we even get into the on card click, we need to write a function up here to cancel our previous job if we need to. So private fun cancel previous job. And basically this previous job is going to be whatever is stored in our delayed compare job function. So, or our delayed compare job value up above that's holding that job. So in here, I need to get the index of my first 2 cards. So I could say val first index is equal to state.value.card1, and then val second index is going to be equal to state.value.card2. And then after that, we basically we've got the 2 indexes for what we need to compare. So I need to have an if statement down here, and I can say if delayed compared job is not equal to null, and then inside of here, we need to cancel our delayed compared job. And so we cancel our delayed compare job, and then we need to actually compare the first index with the second index. Because again, on that app, obviously, these are being compared, and if they match, we're marking it green and then increasing our matched count. But if they don't match, we just flip them back. So here we can see these 2 are going to be a match. So if I click here, that'll match. But this one, if I click on something that, well, I guess they're all going to match now. If I click on one that's not matching, they wait 2 seconds and then flip back, but we need to still compare them to see if they're going to match. So I need a function actually in here after my delayed click for comparing those 2. So again, above this cancel previous job function, we're going to need a function for comparing our values. So private fun compare values, and this is just going to take the 2 indexes that we have up here, which are going to be nullable ints. If you remember, we used that in the state. So in here, we're going to say first is equal to, or is of type nullable int, and then second is also of type nullable int. And then inside of this function, basically all we need to do is pull a copy of the cards from our state, and then if both of them are not null, we need to compare them to each other and then update the state. So to do that, I could say val cards equals state.value.cards.copy of, and now we have a cards array locally that we can use, so we don't have to type that whole thing out every time. And then I say if second is not equal to null and first is not equal to null, then we're going to go ahead and run our comparison code in here. So I can say val card1, which is the card that we want to compare, is going to be equal to cards at our first index. And then card2 is going to be equal to cards at our second index. So with those, all I need to do now is say if card1.value does not equal card2.value. So if they're not equal to each other, then we need to basically flip them back over. So to do that, we can say cards first dot flip card, and then cards second dot flip card, and then that's for if they don't match. But if they do match, we need to say else. In here, we basically need to update the match found property on those cards. So cards first dot match found is equal to true, and then same thing on the second one, cards second dot match found is also equal to true. And then after that, we need to update our state here. So to do that, we could say state dot value is equal to state dot value dot copy. And then inside of here, I can say cards is equal to cards. Pairs matched is equal to state dot value dot pairs matched. And actually, this needs to be pairs matched plus 1 because we've obviously matched it right there. And let's see, one more thing that we need to do. We need to reset in our state. You could see that we have our cards array, which we're updating, but also we have card 1 and card 2. And after I've compared them, I want to set these both back to null and flip them back so that we're not using them again. Because otherwise we'll be comparing the next card, which should be the first card, to the previous card. But we don't want to do that because in memory, once you flip 2, you flip them back, both of them, and then flip 2 more. So let's come back into our view model. And basically in here, we need to reset our compare cards. And let's see, let's go ahead and just make a function for that as well. And I can say private fun reset compare cards. And now inside of here, I'm just going to say if state.value.card2 does not equal null. So if it's not already null, then we're going to do a state.value equals state.value.copy to set that back to null for both of those. And in here, we just say card1 equal null, card2 is equal to null. So now let's go ahead and take this new function that we made and call it at the end of this function. And we should be good to go with our compares value function. So let's come back to our cancel. Let's see, we did cancel previous job. Right, so in our cancel previous job function, after we cancel our job, we need to actually run this compare values function. So we could say first index, comma, second index. And basically what this is going to do is it's going to check if there's a job running here. And if there is, it's going to cancel it and then immediately compare the two. So now that we have this cancel previous job function, we need to go back to our onClick function, which is on event, on card click. Where did I put that? Go to declaration. Here it is. We haven't done anything yet. Okay, cancel previous job is the first thing that we're going to do inside of that function. Then we're going to need to get our cards list, or our array rather. So val cards is going to be equal to state.value.cards, which is going to be our cards array from our state. And then basically we have this ID here. And if that card is already displaying the back, or is still displaying the back, we need to flip it over and then run all of our comparisons. So we could say if cards at ID dot is back displayed, then inside of here we need to set our job first of all. So delayed compare job is going to be equal to view model scope dot launch, and in here we'll just do dispatchers.io, dispatchers.io, and then down in here, and we're just doing that because we're doing a delayed function here, and we don't want it to mess with our main thread or our UI or our interface. So down here, basically we need to flip the card, and then we need to pull cards 1 and cards 2, get their indexes, make sure that their cards actually aren't null, and then compare the two. And if they match, we need to update it to green immediately. And if they don't match, we need to wait 2 seconds so the user has some time to see what's going on, and then flip them back. So to do that, I'm going to make another function in here, private fun flip. And in this function, all we're going to do basically is just simply flip a card. So this is going to take an ID of type int. And then in this flip function, all we're going to do is say val cards is equal to state.value.cards dot copy of. And then in here, we can say cards ID dot flip card. And then after we flip the card, we can say val card2 is going to be equal to state.value.card1. Basically, what we're going to do is we're going to take the value from card 1 and store it in card 2. And then we're going to set card 1 to the new value coming in. So we could say state.value is equal to state.value dot copy, and then inside here we can say card 1 is equal to this ID coming in, so the new one. Card 2 is going to be equal to this card 2 variable that we just took from card 1, the old value of card 1 at least. So card 2 is going to be equal to card 2, and then cards is going to be equal to cards. So basically what we've done here is we've taken the value from 2, or from 1 rather, and stored it into 2, taken the new value and then put it into 1, and then updated our cards array. So what this is going to do is it's going to, if the first one is null, then number 2 will be null and the first one will be populated. But if the second one is, the first one is populated, then they're both going to be populated, and then we'll know it's time to actually run our comparison here. So now that we have that, we can come back up into our onCardClick function, and basically we need to use our flip card function. So I'm going to say flip, and this is going to be, we just hand in the ID that we're getting from our event here. And then after that, we're going to get the indexes of the cards that we want. So val first index is going to be equal to state.value.card1. And then val second index is going to be equal to state.value.card2. And then here we just need to check 2 things. We need to check 1, that both of these indexes are not set to null right now, because if one of them or both of, if one or two of them are set to null, we know it's not time to compare these cards. We can just keep waiting for another card to flip. So here I'm going to have a Boolean variable. So val both cards are not null is going to be equal to first index is not equal to null, and second index is not equal to null. And then after that, we could say val cards match skip delay. And this is going to be equal to if both cards are not null, then we're going to return the value of these cards, of the comparison between the values on these cards. So cards at my first index, and we can say dot value, and I can do this non-null assertion here because we've already run this both cards are not null check, and that's what up here we're checking. So I don't need to worry about that. That's not going to give me any issues. So if that equals cards second index, again non-null, dot value. So here we're comparing both of those. We're going to return the statement of that, but if these are null, basically all we need to return there is false. So else false. Now that we have that, all we need to do here is say if not cards match skip delay. So if we don't want to skip the delay, then we want to say delay 2000 milliseconds, which is obviously 2 seconds, and I think that's about the right time. You can adjust that to whatever you like. And then after that, we're just going to run our compare values function again with our first index and our second index. And with all of that, there's just one more thing that we need to do for this on click. And basically, anytime we click on a card, if you look here, let me pull up that app one more time. If I put this all the way down and I win this game, you can see we're actually counting how many clicks that we did so that we can use that for the score. So to do that, let's add one more private function in here, private fun increase click count. And basically, all we're going to need to do is increase that click count number in our state. So we could say state dot value is equal to state dot value dot click count, or actually rather dot copy, and then inside of the dot copy we can say click count is equal to state dot value dot click count plus 1. And now that we have that, let's just take this function and inside of our on click function, go ahead and apply it there. And basically what we're going to do on this, we only want this click count to apply when we're clicking the back of a card. But if I'm clicking like the front of the card again, I don't want this to apply. So in our UI, we're going to handle this by having two different cards that are actually displayed. And only the one that has the back displayed is even going to register this on click count event. So to do that, we should actually be done with this on click count event now. So we have this. The only thing left is this looks a little bit messy. So I'm going to cut that out and make one more function down here and say private fun set next theme, and paste that code in here. And now above in our on event, we're just going to paste that because now this looks just a little bit cleaner. Hopefully you're learning a lot from this tutorial. We've actually just finished up our view model. So the only thing that we have left is actually implementing our UI. We're going to go ahead and get started on that. But I'm going to put a checkpoint at this point and put all of that code up on GitHub so you can compare the code that you have, or if you're just joining us, you can grab that code and build the UI with us. Now, if you're enjoying this video and if you're learning a lot, make sure to like our video and then subscribe to our channel so that you don't miss any future content like this. Let's go ahead and start building our UI. I'm going to make a few components before we make the actual full screen. So we're going to do new package, and then we're just going to call this components. And then inside of our components, basically, if you look on our device here, you've got this button row at the bottom, and I'm going to turn that into a component to generate just one of these buttons and then the entire row. And then also we have this memory card up top, which we're going to have a composable function to determine what that looks like as well. So let's go ahead and build that. In memory screen, or rather in components, we're going to do a new Kotlin class or file. And I'm just going to call this one buttons, make it a file, and then at composable, fun, and then this function is basically going to be for generating our button row. So we're going to call it build buttons. Inside of here, we're going to pass the view model into it, which is actually not going to be a view model type, but a memory view model type. And then after that, I'm going to pass a modifier of type modifier, which is going to be equal to our default modifier. And let's go ahead and import this memory view model. Import that modifier. And give this function some brackets. Okay, so if we look here, you've got one button, two buttons, and then a reset, and then this image button. So these three are actually quite similar. They all have the same color, and they all have the same, they have the same color, and they're going to take one lambda, and the only difference is going to be the icon. So to build those, I'm actually going to build a function first called icon button. So this is going to be a composable function icon button, and we'll worry about the parameters in a minute. So in this function, we're going to need a box, and we'll take a modifier, which is just going to be equal to a modifier parameter that we pass in. So let's go ahead and put that modifier up here. We'll say modifier of type modifier, which is by default going to be equal to just a modifier. But we are going to actually pass one in there. So there we've got that. And then inside of this box, we're going to have pretty much a button and then an icon on that button. So inside of the box, I can say button, and we want this one here with the on-click lambda. Okay, so there's a few more things that we need to actually pass in here. First, obviously, we need that on-click for the button. So I'm going to say on-click, which is just going to be a empty function that we pass in. And then we need an icon, which is going to be this image vector that's changing. So our icon is going to be image vector, and then a content description, which is going to be a string, obviously. And then just the color of what we want that icon to be. So we'll just call that our tint, which is going to be a color. Okay, and that should be all we need for the parameters. Now down here, our onClick, we're just going to simply set that equal to the onClick function coming in. And then where our shape is going to be a circle shape. And then our colors, we are going to set that equal to button defaults dot button colors. And then inside of here, we can say color dot transparent. And that way you only get the icon, but you still get the button functionality, but you can see right through that button. So after that, we've got everything we need there. Inside of that button, we need an icon. And this is where we need to define our image vector. So here I say image vector is equal to icon, and then our content description is going to be equal to our content description coming in, and then our tint is equal to our tint color as well. And finally, our modifier is going to be equal to modifier.size, and we're just going to do 80 data pixels. I think that's a good size for a button, and we're not going to need to worry about that. Okay. There we go. This icon button function is done. So now with that icon button function done, let's come back up to our build buttons composable. And in here, we can say val state is equal to our view model dot state, which is that public state in the view model that we can basically have read-only access to. And then in here, I'm just going to do all 4 buttons, and I'm not actually going to put this in a row or a column, because if you look on here, it's obviously in a row right now, but if I was to rotate this phone, you can see now it's actually aligned in a column. So depending on if we're portrait or landscape, this is going to be aligned differently. And instead of making 2 different functions here, one with these buttons in a column and then one with these buttons in a row, what I'm going to do is just make a single function and then pass that into either a row or a column, depending on if we're in landscape or portrait mode. So to do that, basically in here, all I need to do is lay out my buttons. So I can say icon button, and then inside of here, we can say on click is equal to, so this will be our, we'll make this our up arrow, the first button here that you can see. So this is going to be view model dot on event, and then this is going to be a memory event dot add pair. And then with that, we can say icon is going to be equal to icons dot default dot, we're going to use this keyboard up arrow. And then after that, I can say content description is equal to our, this is just going to be add pair button. And really, we should put all these strings into our constants file. But this is a pretty small project, so I'm not following all of the best practices. But obviously, if you're making a large project, put these strings in your constants file. Don't just hard code them into there. And then I'm going to say tint equals state dot current theme dot, and this is going to be our reset icon color. So why is that not working? State dot, oh, of course, we can't set our state equal to state. What really we need is our state dot value. We need the value of that state. So we have tint equals state dot current theme reset color, and then finally let's pass in that modifier. Okay, so with that, all I need to do is copy that, paste that 2 more times for our down arrow and then our reset. And then here, all we need to do is instead of add pair, we're going to do reduce pairs. And then instead of add pair button, we're going to call this our reduce pairs button. And then this reset icon. Okay, so we actually named that in our theme reset icon. We probably just want that to be icon color. So let's go back to our theme, find that reset icon color, and we're going to refactor and rename that one. So this we actually just want to be icon color. And now if we come back to our buttons, this is just our current theme.icon color. So that's what we want. We've got reduce pairs. Instead of keyboard up arrow, we want keyboard down arrow. Keyboard arrow down. And then reduce pairs, that should be all we need there. And then for this third one, instead of add pair, we want this to be reset game. And then instead of add pair button, we want this to be reset game button. And then our icon color is fine. So now at this point, all we need to do is make this image icon down there. So to do that, I can say box, and this is going to have a modifier, which is equal to our modifier that we're passing in. And then inside of this box, we're going to put a button. And this on click is going to be equal to our set next theme in the view model. So we could say view model dot on event, and this event is going to be a memory event dot change theme. And then our shape on this button, just to match all of the other ones, we're going to keep that circle. So circle shape. Colors is going to be equal to, let's put a comma after that so we don't get errors. Colors is equal to button defaults, whoops, not that, button defaults dot button colors, and then inside of here we're going to do color transparent again, so that way we only actually get the image, but we still have all the button functionality on there, we just can't see it. And then inside of that button row, we're just going to have an image, and inside of there we're going to do painter resource, or rather we're going to do painter is equal to a painter resource with an ID equals state dot current theme dot get image resource for number, and this is going to be number 1, because basically what we did is we took the number 1 image and we just set that as our theme logo as well. And in here we'll assert that that's not null, because we know for sure that that's not null. And I can say yeah, let's go ahead and, no, not create that. We want to finish this out. We need a content description is equal to switch switch theme, and then our modifier is going to be equal to a modifier dot fill max size, and this one I'm not passing the one all the way through, I'm just making a new one here. Let's import that function. Let's import that image function. And then one more thing I'm going to do is content scale is equal to content scale dot fit. And that way we just get the whole image. We're not going to crop any part of that there. So that's all that we need for the build buttons function. So now we can use that within our screen. Now with that done, let's go ahead and build our memory card component. So right click on components, and we're going to do a new Kotlin class or file, and we're going to call this memory game card. And then inside of here, we're going to have a composable function. This is going to be fun, and then memory game card, just like the file name. And then inside of the parameters for this memory game card function, we're going to pass it a card of type memory card, which is our model class memory card, and then a modifier, which is going to have a default of just the default modifier, and then state, which is going to be a memory state. And finally, we're going to pass it our onClick, which is going to be lambda. Okay, now within this memory card, basically we're actually going to build 2 card composables, one for the display if the back is shown, and one for the display if the front is shown. So to do that, all we're going to do is if card.isBackDisplayed. Well, then in here, we're going to put our back, or if the back isn't displayed, then we need to put our front display in here. So let's start off with the isBackDisplayed. So inside of here, the first thing that we're going to need is going to be a card. Inside of this card, we can say shape equals rounded corner shape, maybe 12 data pixels. I think it looks about right. So we'll go with 12 data pixels on that one. Our onClick is going to be equal to our onClick parameter that's coming in. And then our colors is going to be equal to card defaults dot card colors. And then in here, we're just going to say our container color is equal to our state dot current theme dot card base color. After that, we can say elevation is equal to card defaults dot card elevation, and in here we could say our default elevation is going to be 6 data pixels. I think gives a decent shadow for that. And then after that, our modifier is just going to be equal to our modifier parameter that we passed in. And now inside of this card, let's see, why is that? Okay, we need to opt in for this experimental material 3 API. So let's go ahead and do that. Now, inside of this card, we are going to have a box. And let's go ahead and import that as well. Now, for the modifier on this box, we are going to need this equal to modifier dot fill max size. And then we're actually going to need one more modifier on here, but we can't do that yet because I'll show you why in a second. So after the modifier, let's do a content alignment, and we'll do alignment dot center. Okay, now for that last modifier that we have up here, we're going to need to actually calculate this card, the picture, how it's displayed. So basically, if you look in our this image that I have here, which is our background image, it's not a square and it doesn't fit the card. It's 474 by 711, which if you divide those numbers width over height, that comes to an aspect ratio of 0.66 repeating, I think. So let's exit out of that and look at here. Depending on how many rows we have in this card, this can be different sizes. So if I only have 2, for example, the card is really high. So if I do fit width here, then we're going to have some extra margin on the top and the bottom. But if I come all the way down the other way and I have a lot of cards here, now it's really short. So if to compensate for this scenario, I do fill height instead, well, now when I get here and I do fill height, I'll have bars on the sides, and I don't want that. So what I'm actually going to do is I'm going to add a few more variables to calculate the aspect ratio of our card so that we can know whether we want to fit this image to the height or to the width of this box. And to do that, I'm going to need a few more variables up above. So val local density is going to be equal to local density dot current, and then val card height by, remember, this is going to be mutable state of, this will be 0 data pixels. Then let's make sure to import that, copy that line. And actually, when we import that, there's going to be, we need to do the get value and the set value as well. So copy that line, and instead of card height, now we're going to say card width, which is going to be 0 data pixels. And then now, inside of our modifier down here, we need to actually calculate what these values are. So to do that, I can add another modifier, and I can say on globally positioned, and we're going to say coordinates. Now in here, we could say card height is actually, and these are, let's see, card height is going to be equal to width, local density, and then in here, we could say coordinates dot size dot height dot 2dp. Now, I guess we better change that to a var. Same thing, both of these need to be vars, not vals, because we're modifying that. Now we can copy that line. Let's paste it one more time down here, and instead of card height, this time we're going to say card width equals the same thing, except instead of height, we need width here. And then up top, we need to actually import the set value function as well. And now that we have that, this is going to actually return the height and width of our current card. And that way we can calculate the aspect ratio so that we can know how best to lay out our image inside of that card. So with that being said, let's go ahead and calculate that aspect ratio. So we could say val card aspect ratio is equal to card width divided by card height. And then down here, we can say val should use, so this is just going to be my Boolean variable to tell me if we should use fill width or fill height. And I could say should use fill width equals to card aspect ratio greater than, and now we need to, I told you the aspect ratio of this card was about 0.66f, so we could do that. But instead of putting that there, let's go ahead and put that into our constants file. So in here, we can say const val card image aspect ratio equals 0.66f, which is what you get when you divide 474 divided by 711, which we are getting from the resolution of this image that we used here. So now that I have that, let's come back to my memory game card, and I can say if this aspect ratio is greater than my card image aspect ratio, well, then we can go ahead and finish the rest of this card here. So now we can put the image in here. We can say painter equals painter resource, where the ID is going to be state dot current theme dot card back. Our content description is going to be equal to back of card image. Let's make sure to import that painter there, or that image rather. And then in here, we can say content scale equals, and here we could say if should use fill width, then we're going to do content scale dot fill width, else we're going to do content scale dot fill height. And that's what all of these calculations up here, and finding that aspect ratio was for, because now we know how to position that image on the back of our card. And then after that, I could say modifier is equal to our modifier dot fill max size. And that way this image is just going to stretch out over the whole card. And then after that, we'll say alignment is going to be equal to alignment dot center. And that should be everything we need for that image. Now we also have this question mark that we're putting over that image. So to do that, I'm just going to have a simple text down here. Inside of there, we can say text is equal to question mark. Font size is equal to, I think 70 SP looks about right. And then we can say font weight is going to be equal to font weight dot, we're going to do extra bold here to make that really stand out. Color is going to be equal to state dot current theme dot text color. And then finally, our style is going to be equal to text style. And then inside of here, we're going to add, basically we're going to add a shadow, just because we want this text to really stand out from the background. So just having a little bit of a darker shadow behind it is just going to make it separate. It's going to separate that from the background just a little bit more. So to do that, I can say shadow is equal to a shadow, and our color is going to be equal to color dot black. Offset, we're going to say is equal to offset, and this is going to be 1F and 0F. And this is really just me playing around with values and see what looks good, kind of. And then in here, we can say blur radius is going to be equal to 40F. So now make sure to get all of that imported. And now we should be good with the back of the card. So we can come down here and go ahead and build out the front of the card for when we have that flipped over. And in here, I'm going to say val border modifier is going to be equal to if card dot match found, then our modifier dot border, and here we're going to say this is going to have a width of 4 data pixels, and we're going to have a shape of a rounded corner shape with 12 data pixels to match our card shape. And then our color is going to be equal to state dot current theme dot matched outline color. And here we have our if, so then we need our else. So else is just going to be a normal modifier. Now we're going to make another card down here inside of this else statement. And basically for this card, I'm going to say outlined card. And let's pass a few parameters in here. We're going to say our shape is going to be equal to our rounded corner shape with a 12 data pixel size so that both sides of the cards are the same. We can say colors is equal to card. Here we'll say card default dot card colors. And then inside of card colors, we can hand our container color, which is going to be state dot current theme dot card front base color. And then after that, let's put some elevation on this card as well. So our elevation is going to be card defaults dot card elevation. And then inside of here, I could say default elevation is equal to 6 data pixels, which I think looks about right. But now we need to actually pass in our border modifier. So to do that, down here, we can just say modifier is equal to our border modifier. And that should give us the card that we want. Now, inside of that card, we need to actually populate some content there. So to do that, inside of the card, I'm going to have a box. And then inside of that box, first in the parameters, let's go ahead and add that. I'm going to say our modifier is going to be equal to a default modifier. And then in here, we'll do dot padding. I think 12 data pixels is a good value for that, so we'll go with that. And then I'm going to say dot fill max size. After we've got that filling the max size, we're going to say content alignment is equal to alignment dot center. And then with that, really all that we need to display in this card is that image. So if I flip one of these over, you see we have that picture and it's just on an outlined card with the background set to that tan color. So here, all I need to do is say image. And in here, I can say my painter is going to be equal to a painter resource. And the ID is state.currentTheme.getImageResource for number. And then this is going to be card.value. And I'm going to assert not null on this one. So there's our painter resource. And then after that, we can say our modifier is going to be equal to a default modifier dot fill max size. And that's just going to stretch it out for everything, the whole area of that card except the padding. And then our content description is going to be equal to memory card dollar. And then here we can say card.value. And that way, if this is the first card, it'll say memory card 1. If it's the second card, it'll say memory card 2. And it's good to have descriptive dynamic titles like that or content descriptions like that, because that way, if someone was actually blind and they're playing this, they can still play this game just based off of that content description. And then we can say our content scale is equal to content scale.fit. And finally, our alignment is going to be equal to alignment.center. So that should be pretty much everything we need. That should take care of our memory game card. Now we're done with all the components we need. We can actually come in here and do a new Kotlin class or file, and we can just call this one memory screen. Whoops, just like that, memory screen. Now, inside of this file, we're going to have an immediate challenge here. And basically, if you look at this screen, our grid is changing based on how many cards that we have. So if we have just 4, it's 2 by 2, and that makes sense. But if we go higher, now it's 2 by 3, now it's 3 by 3, but the third row you have a gap there, and it just keeps changing every time. Now on top of that, we have the grid is actually going to be the opposite this way. So now you have 2 by 2, then you have 2 by 3 and 2 by 4, and it just keeps going. So depending on if your portrait or landscape, depending on which way your screen is rotated at the given moment, this is going to actually differ. Your grid is going to differ, and how we build that grid is going to differ. So to do that, basically what I'm going to do is I'm going to build each one of these in a separate row, and I'm going to have a function to build a row of cards. And for that row of cards, I'm going to pass in a range of numbers, and it'll build that many cards at that index in our state array. So to do that, like this way, I'm going to need to pass in 6 arrays, or 6 ranges rather, of length 3. And if I'm rotated this way, well, now I need to pass in, let's see, now I need to pass in 3 rows, or 3 ranges with a length of 6. So to do all that, I'm actually not going to do all the code to calculate that. Instead, I'm just going to predefine those ranges. And I'm going to put that function in my util class. So we'll do new Kotlin class or file. This is going to be a file. We'll call it row ranges. And now in here, I'm just going to have a function that says calculate row ranges, which is going to take in a pair count, which is going to be the number of pairs that we have here. And then an is portrait variable, which is going to be of type Boolean, and that's going to tell us our screen rotation state. And then we'll have list. We're going to pass back a list of int ranges, and then based on that list of int ranges, we're going to be able to build out our rows in a grid on the screen. So to do that, in here we could say return when is portrait. And then down here, I could say true. If it's true, we're going to run this code. And then if it's false, we're going to run this code in here. So to do that, I could say when pair count. And then in here, I'm going to have, let's see, we're going to have 2 is our lowest pair count that we're going to allow in this app. So list of, and this is going to be 0.1 and then 2.3. And that, if you come all the way down here, and actually we're in portrait mode here, so we're like that. So if I come all the way down to 2, you can see we just have 0 to 1, and then we have 2 to 3. So that's all we need for 2. Let me just go ahead and copy that and paste that. Let's see, 2, 3, 4, 5, 6, 7, 9, else, list of, and we'll just do an empty list. Let's just actually do an empty list like that. And then up in here, we need to say 2. That needs to be 3, 4, 5, 6, 7, 8, 9. So 9 is just our maximum value. And then here, if we go up 1, well, now we have 3 rows of 2. So I'm going to add another range here, and it's going to be 4.5. Now, if I go up 1 more, now they're rows of 3. So this is going to be, instead of to 1, it's going to be 2, which means this one's going to start at 3. And if I start at 3, I need to not go to 3 anymore. I need to go to 5. And then finally, I need to go 6.7. And the reason that this one only has 2 is because obviously in the last row, we only have 2 cards. Next, we can actually just copy all of these values, paste them down here. And again, if we increase this, you can see we add 1 more row with just 1. So we're going to go 6, 7, 8 in that row. And then we're going to do 9 to 9. And then let's copy that again. Paste it down here. And if we click 1 more, now we haven't added another row. We've just gone from 9 to 11. So let's copy that one. Click 1 more, and now you can see we have another row with 2. So paste that, and then we have a little more room here. Instead of ending at that row, we're going to add 1 more row, which is going to be 12.13. And then if I add 1 more, you could see I finish out that row with 1 card, and then I add 1 card to the next row. So this is now going to be 14, and then we're going to go 15.15. And finally, if I complete that, all I need to do is copy all of this, paste that down into this bottom one here, and we can go, instead of 15.15, we'll just go 15.17. So that is for when we are in portrait, but when portrait is false, we'll basically do the same thing. We can have a when statement in here for pair count, and then inside of there, we can say 2, going to be a list of, actually that one's just going to be the same. But anyway, we'll copy. So this bottom one is going to be an empty list, and this is going to be my else, and then this will be 2, 3, 4, 5, 6, 7, 8, 9. Now these are actually going to be different. So if I rotate the phone, and then if I go all the way back down, it's going to start out the same, which is just going to be this 0 to 1 and then 2 to 3. But very quickly, you'll notice if I increase that, now we've added another column essentially. But because we're only calculating rows, what we need to do is have longer rows here. So to do that, this one is going to be, instead of going from 0 to 1, I'm going to go to 0 to 2. And then instead of starting at 2, I'm going to start at 3 and go all the way to 5. And then if I add another one there, you can see I've done the same thing. So in here, I'm going to go 0 dot dot 3, because now this is a row of 4. So 0, 1, 2, 3. And then the next one is going to be 4 to 7. And then after that, if I increase that again, well, now the first two rows have stayed the same, and I've added a third row. So I can copy that, paste it down here, and then just add a third row, which is going to be 8 dot dot 9. And then if I keep going, so if I add one more, now I just go to 11. So I'm going to copy that line again, paste it there, go to 11. And then if I increase it again, so now I've added another column there. So I'm going to actually need to change the length of these rows. So I'm going to say 0 dot dot 5 now, because we're going to go 0, 1, 2, 3, 4. Yeah, sorry, not dot dot 5, 0 dot dot 4. And then after that, I'm going to say 5 all the way to 9, which is going to be 5 cards long. And then 5 through 9, and then we'll have 10 through 13, because again, we're missing one there. And then let's just increase that again. So you'll notice we added yet another column there. So here now I'm going to say 0 to 5, and then we're going to do 6 to 11. And then after that, we're going to do 12 all the way to 15. And for the last row, we're just going to add in those 2 cards, which means we only need to add in our last 2 additional cards. So we can copy that, paste it, and then instead of 15, we can do 17. And basically, this grid here is what we're going to use to determine how we build out all of our cards. So now, if we go back to that memory screen that we were building, in here, we're going to add a composable function. And this is just going to be called memory screen. We're going to pass in a modifier, which by default is just going to be the default modifier. And then I'm going to have a view model as well, which is a memory view model coming in. Now, inside of this memory screen, in here, I'm going to say val configuration is equal to local configuration dot current. And we're going to use that so that we can then determine if we're in portrait or landscape mode. So I can say val is portrait, and this is going to be equal to configuration dot orientation, and this is equal to android dot content dot res dot configuration dot orientation portrait. So basically, if we're in portrait orientation, that's going to come back as true. And then we'll be able to adjust our composables based off of that. Then in addition to that, we need a state. So val state is going to be equal to viewModel.state.value. And then our background image. So we could say val background image is equal to if is portrait. And then we could say state dot current theme dot background portrait. And then we can say, let's just actually get rid of those brackets. We don't need those. So we can say if is portrait, then we'll hand back state dot current theme background portrait. Else we'll hand back state dot current theme dot background landscape. And then after the background image, we're basically going to put this entire screen inside of a box. So I can say box, and then inside here, our modifier is going to be equal to our modifier that we passed in, and we're going to call fill max size on that. Let's go ahead and import the box. And then down here in the body of the box, we are going to start off with the background image, which is just going to be an image. And then in here, our painter is going to be our painter resource where the ID is equal to our background image that we defined up here. And then our content description is just going to be our background image. And for this, we're going to say content scale dot fill bounds. Whoops, I need content scale is equal to content scale dot fill bounds. And then after that, we can say modifier is equal to modifier dot fill max size. So what this is going to do is basically it's going to take our image and stretch it out and fill it for the entire bounds of the screen so that the background covers everything. Then after that, we need to have a row. So I can say row, and then inside of our row, let me just import that really quick. Okay, so inside of this row, basically, we're going to build out this entire grid. So first, I'm going to say modifier is equal to modifier dot fill max size. So that way this row is going to take up all that it can. And then inside of here, we're going to say val row range is equal to calculate row ranges, and our match count, or our pair count rather, I think I named it, pair count is going to be equal to state dot pair count, and then is portrait is going to be equal to our is portrait variable that we got up here. And then after that, basically we need to have a if statement down here and determine how we're going to display all of this information based on if we're in portrait or landscape mode. So if is portrait, then we're going to do that. Else, we're going to do this. Okay, so the first things first, if we're in portrait mode, then we already have a row. We're basically going to put all of our, we need to build out all of our rows, and we need to build the rows in a column so that they're on top of each other. So the first thing I'm going to do is add a column here, and we're going to say modifier is equal to modifier, and then we can say dot fill max size, and then I'm just going to have a little bit of padding on that. At the top at least, we'll say top is equal to 18 data pixels of padding. Okay, and then after the modifier, we can say vertical arrangement is equal to arrangement dot, I'm going to say space between, and then my horizontal alignment is going to be equal to alignment dot center horizontally. And then inside of this column, basically, we could say for range in row ranges. Let's actually make this plural. So for range in row ranges, then we need to actually go ahead and build out everything here. But before we do that, let's just add the buttons at the bottom, because I'm going to go ahead and make another function to actually build out each row here. So before we get to that, after all of these ranges are built, we are going to have one more row down here. And inside of this row, we are going to have, let's see, inside of this row, our modifier is going to be equal to modifier dot weight. And this is going to be 0.5f. And basically, I'm going to weight each of these rows 1 and then this bottom row 0.5. And that way, these take up more room than the bottom one, so our buttons don't take up too much of the screen. And then after the weight, we can say fill max width, which is going to stretch that across the entire screen. And then dot padding, we'll say top is going to be equal to 4 data pixels. And then bottom, same thing, we'll do 4 data pixels. And then inside of this column, we'll say vertical alignment equals alignment dot center vertically. And then we can say horizontal arrangement is going to be equal to arrangement dot space between. Okay, now inside of this row, all I need to actually do is call that build buttons function that I've already created. And my view model is just going to be the view model that I have inside of this screen. And then finally, my modifier here is just going to be a modifier with a weight of 1f. And that way they'll all be weighted equally. Okay, so now basically we need to come up here and figure out what we're going to do for this build row ranges function. So down here, we'll just go ahead and make another function. And we have these ranges, so this shouldn't actually be that difficult. It's going to need to be a composable function. And then fun build, actually this is composable, so we should use a capital B, build card row. Okay, so in this build card row function, we're going to need a modifier. And by default, we can just set that equal to the default modifier there. And we're going to need a range, which is going to be an int range that we're getting from our function for calculating that. And then we can say number of rows, which is going to be int. And we can say view model. We're going to pass in our memory view model for that, as well as if the current row that we're passing in is the last row or not. Just because if it's the last row and we have a number like this where it's not divisible by 3, then we need to add some spacing for the additional cards so that this bottom one doesn't end up taking up the entire width of the screen. So is last row, we're going to by default set that equal to false. And then in here, we can say val state equals view model dot state dot value, and that way we'll have a state that we can work with without having to type that whole thing out every time. Now in here, we're going to have a box, and our modifier is just going to be equal to the parameter modifier that we pass in. And then inside of this box, I can say horizontal arrangement is equal to arrangement dot, we're going to say space between, and then our vertical alignment. Whoops, what's going on here? Sorry, we're building a row. So the box is just a wrapper for the row so that we can pass in a modifier with the right weighting so that this turns out the right size on the screen. But we actually need a row in here before we can start arranging things inside of it. So let me cut that out, paste it up inside of here. And then we can say vertical alignment is going to be equal to alignment dot center vertically. and our modifier is going to be equal to our parameter modifier dot padding, and we'll say maybe 8 data pixels of padding should look about right, and dot fill max size. Now inside of this row here, basically we need to actually put all of our cards there. So we can say for card ID in range, then inside of here, I can say memory game card, and we'll have to pass in some parameters to that. I can say my card is equal to my state dot cards at my card ID, and then my state is just going to be equal to my state. My modifier is going to be equal to a modifier, and here I'm just going to pass that maybe 6 data pixels of padding. So we'll say 6 data pixels, and then dot fill max size. And finally, in here, let's go ahead and add an on click, which is going to be equal to our view model dot on event. And then this is going to be a memory event dot card click. And we are going to pass this our card ID for the index there. And that really should be, let's see, for card, what are these extra brackets doing down here? I don't need those. Okay, so that's going to go through every ID in our range and build all of those out. So now we have just a few problems with this. Let me build out a preview actually down here just to show you what we need to fix. So at preview, show background. Well, I don't even care if it's a background. We'll just say at preview. And then in here, this is going to be a composable. This will be fun memory preview. And then in here, we'll say val, our view model is going to be equal to a memory view model. And then after that, all we have to do is say memory screen view model equal view model. Now we can switch to split mode and build and refresh our code so that we can see what this looks like. And of course, the view model by default is going to have 6 rows in it. So, okay. So first things first, we have to actually call this function from above. So let's go back up here and find right in here for ranges in there. And then we need to call this build card row. And basically inside of this build card row, we need to hand it all the parameters that we specified. So come on in here, we can say range is equal to the range from this loop here. And then we'll say number of rows is equal to row ranges dot count. And then we can say view model is equal to our view model, and our modifier is going to be equal to a modifier dot weight. So because we're in a column scope here, I can use that weight, and I can say weight dot 1f, and then I can say is last row is equal to row ranges dot last equals range. Okay. So let's give that preview a second to render. And you'll notice an immediate problem here, and it's that each card actually takes up the entire row. So the reason for that is down here, we have our memory card that we're building, and we just build it without wrapping that in a box and handing in a weight, because we have this fill max size modifier. So what we could do is say, well, okay, in this row we have, at least right now, we have 3 cards. So I could say, let's give that maybe 0.3f on the fill max size. But the problem with that is when that happens, or when we apply that, this is not gonna, yeah, you can see what it's doing here. It's not gonna work at all. Basically, the first one is wider than the rest, and then the second one is that the height is the same, but the width is a little bit less. And then the third one, it's even less than that. So what is going on here is basically we have this weight that we're passing down from this row that we're in. And what we need to do is instead of using our 0.3f for our fill max size here, what we actually need to do is we need to make a box here. And then inside of our box, we need to put this memory card because we can't apply a weight modifier to this card ID, but we can apply a weight modifier to this box ID. So here, if I say my modifier is equal to a modifier dot, and then I say weight, and in here I say we'll say 1f so that they're just all equal. What I can now do is I can grab this memory card item, cut that out, paste it inside of my box, and now because each memory card item within this row has a weight of 1f, they should all be spaced out equally whenever this render finishes. And there we go. So now we've got 3, 3, 3, 3. Now they're all about the same size, but you'll notice if you zoom in here, you can actually see a little bit of our card base color hanging out the side. So we don't want that there. So what I'm going to do here is on this box, we can add a fill max size, and that's just going to stretch it out so that it fills that whole thing. But there's actually still going to be one more problem with the way that we have this laid out right now. Let me I don't know why that render didn't update before, but it updated after I clicked build. So anyway, there you go. Now it's stretched out over the entire card. Actually, it's not stretched, it's just fit. The width is fit to the entire card. But you'll remember here, this is a nice even number. So we defaulted to 6 for starting, 6 pairs that is, which is going to give us 12 cards, which is easily divisible by 3 into 4 rows. But if I were to maybe open up my memory state, and instead of 6 here, let's try 7 for our default. And now come back to our memory screen. Let's give this a second to render. Now here, you'll notice the bottom 2 cards are not the same width because we're doing a weight of 1 and filling our max size here, which we need to do to get the cards to be the right size up here. But on the last row, we actually need to add this with some extra values in there. So to do that, what I'm going to do is after, let's see, after this for block here, down here, I'm going to say val modulus, meaning modulus division, is going to be equal to state dot pair count multiplied by 2. So that's going to be how many cards that we have. And then we're going to take the modulus of that by the number of rows. So the number of rows here is obviously 5 in this case, but that's going to change. And this is going to give us basically how many extra cards we have to add. So down here, we can say if is last row, which is that parameter that we passed in, and modulus does not equal 0, meaning if it's the last row and we don't have a nice neat number of cards that's divisible by 3, then we need to actually go in here and buffer the cards. So I'm going to say, or not buffer them, we need to add some, we need to add cards as buffers to make them all spaced out evenly. We can say val filler card number is equal to the number of rows minus the modulus, which is this variable that we just calculated up top. And then we can say val extra cards is going to be equal to 1 all the way to the range of the filler card number, so however many that is. And then if we come down here and we say for missing card in extra cards, we are going to go ahead and just say box. And in here, we are going to hand it a modifier, we'll say modifier dot weight of 1F and then dot bill max size. So now this should actually give us some buffer cards. So let's give that a second to render here. Okay, there we go. I don't know why my render is looking like that. It wasn't updating for some reason, but after I clicked build again, it updated. So I think I have some bugs going on that I'll have to worry about later. But essentially now you can see these bottom two cards are in fact the right size. So that's going to be everything that we need. And this, I don't even need these brackets. That's going to be just an empty box, really. And this is going to be pretty much everything that we need for the portrait orientation. But now we need to come up and figure out what to do if it's a landscape orientation. And before we do that, let me just go back to state and set these back to 6 so that we don't lose any of that. Okay, now actually, let me just add that in the constants. So we'll say const val starting pairs equals 6. And then all I need to do is copy that value, come back into my state, and instead of 6 here, we'll do starting pairs. And instead of 6 here, we'll do starting pairs. Okay, now close out of the state, come back to my screen, and we've got everything figured out for the portrait orientation. But now we just need to fill out what to do if this is going to be a landscape orientation. So for that, it's actually going to be quite similar. So I'm going to copy this column up here, paste it down inside of this else column. And then after that, instead of using 18 data pixel padding, we're going to change that up a little bit. So I'm going to say my top is equal to maybe 4 data pixels, and then my bottom will be equal to 4 data pixels. And then just because we don't have quite as much room when we're working in landscape. And then up here, we're going to add a weight onto this and say 4F for this column, because we're going to have the, if we switch this over into landscape mode, we have this button row that we're going to have actually as a column over here, and we don't want that to be too wide. So 4F should help to control that. And then inside of this column, basically all we need to do is call this same build rows function. So this one right here, for range in row ranges. So let me copy all of that, come down here and paste that. And then after we have that, after this first column, we are going to have a second column. So let me just copy that again, paste it down here. And then in this second column, basically, we're just going to have that build buttons function. So I can copy the build buttons again from up here and paste it down here. And again, because we didn't specify the row or the column within the buttons, because I'm putting this now within a column, it's going to build it vertically instead of horizontally. Let me just change a few things here. 4F is going to be way too high for this, so maybe 0.75F for the weight on this column. And then for fill max size, we'll take that. We don't need any of this padding. We'll get rid of that. We can say space between and then center horizontally. That still is all good. So now at this point, really the only thing that we still need is here, if I click on these, you could see when I win the game, it's actually going to give this little display here telling me that I won. So that victory box is the only thing that we have left to add here. So we can go ahead and do that. We're actually going to put this below this if statement entirely. And really, actually, we might even want this, I think we want this below our entire box scope, actually. And basically, what this is going to look like is we can say if state dot pair count is equal to state dot pairs matched, meaning if we've matched everything, the game's over and we need to display our victory box. So here, I'm just going to say box, and this box, we're going to hand in modifier is equal to, we'll do our parameter modifier dot fill max size. And then in here, we can say content alignment equals alignment dot center, just to put that right in the middle of our screen. And then after that, I'm going to put a card in here. And this card, I'm going to say our modifier is equal to modifier dot fill max width. And then here for the max width, I'm actually going to say 0.7f, and that way it won't actually fill the whole screen. And then dot border, and this border is going to have a, let's see, a width of 4 data pixels to be consistent with what we did earlier. Our shape is going to be our rounded corner shape again. And again, for consistency, we'll do 12 data pixels there. And then our color is going to be our state dot current theme dot matched outline color. And then after this, so we've got our modifier there. We'll say colors is equal to card defaults dot card colors. And then in here, our container, our container color is going to be equal to state dot current theme dot card front base color. And now inside of this, we're going to get a column scope with that box. I'm going to stick a row in there. We're going to say row, and then inside of this row, I'm going to say modifier is equal to modifier dot fill max width, and then we'll add some padding on that as well. Maybe top equal 4 data pixels, bottom is also equal to 4 data pixels. And then after that modifier, we'll do our vertical alignment, which will be center vertically. We'll do our horizontal alignment, which we're going to do arrangement dot center. And then down here inside of this row scope, we can just add our text. And that is going to basically just print out that you won. So we can say text equals you have won \n for a new line. And then we're going to say score is $state dot click count. And then we're going to say clicks, because the score is what or the number of clicks is what we're tracking your score within this app. And then after that, let's just format this a little bit. We can say color equals color.black. And then we'll do font size is going to be equal to maybe 30 SP should be about right. And then we can say line height is equal to 38.sp. Modifier is equal to modifier.padding. And we can say maybe 8 data pixels. Okay, now beneath this text, I'm going to add another row. And this row is pretty much going to be the same thing, or the same parameters at least. So we'll copy that. And then inside of this row, I'm just going to add another icon button. And actually, I don't need those brackets at all. I do need to import that. Okay, and then inside of this icon button, I can say on click is equal to, actually what I'm going to do, instead of doing that, let's just go over to our buttons function, and we need to find our reset button, which is going to be this one. Copy that, come back to our memory game card, come back to our memory screen. Let's paste that button in there, and I think that, something's not right here. Let's go back to buttons. So our arrow up is our add pair, reduce pair, arrow down, and then reset button, which does reset, needs to not be our keyboard arrow. This button actually needs to be our refresh button. Okay, now let's copy that icon button, come back to our memory screen, paste it there. Now, with that in place, really, I think the only thing we have left to do is go back to our main activity. And let's actually, well, let's move that memory event. First of all, that needs to be in our memory screen, refactor that. Okay, let's open up our main activity, and all we have to do is make a view model and call this screen. So let's do that. We say val view model of type memory view model by view models. Whoops, not that one. I want this one by view models. And then I can say memory screen. In here, we could say view model is equal to view model. And all I have to do now is run this app and see how it works on my phone. So let's pop this out and have a look at this. Make this just a little bit bigger here. Okay, let's try this. Okay, so this is actually a little bit different than the one that I did. I think I got the wrong color on maybe my Thanksgiving theme, but that's fine. Our grid seems to work fine. Let's come all the way down and try to win and see what happens. Okay, you won 6 clicks. That's working. Let's go fix that color really quick. So in our holiday themes, our card base color, let's see, card front base color, this needs to be tan on our Thanksgiving at least. And then everything else was looking good. So let's try that one more time. There we go. That looks a little bit easier. Let's just check here and see. Man, I'm not good at memory. Let's see how we can find all of this, make sure that we win. I really should have maybe picked an easier version of this to demo on. Okay, there we go. You won 26 clicks. Click refresh, that works. Let's toggle our theme. There's our Halloween theme. That looks good. There's our Christmas theme. That looks good. So I think at this point, we're pretty much done. So you've actually made it through this entire video. You've built out this memory app with all the different themes, with the different levels of difficulty. And it looks actually like a fun game. I had fun building it. Hopefully you had fun too. Let me know in the comments below what themes you implemented that might be different than mine. And then definitely give us any feedback below as well. And make sure to subscribe to our channel so that you don't miss any additional content.